Hi, in this video I'm going to introduce you to generic collections. A collection is an object that can hold references to other objects. The Java Collections Framework provides a number of interfaces for representing and manipulating collections. One of those interfaces is called collection. It's the root interface in the collection hierarchy. List represents an ordered collection, where the user has control where in the collection an element is going to be inserted. Sets are collections that contain no duplicates. Maps are similar to dictionaries. Those are collections that map keys to values. Queues are collections that are designed to hold elements prior to processing. Here is a different view. You can see on top the interface collection, the root interface of the collection hierarchy, and here we have other collections that extend the collection interface. So the list interface extends collection, queue extends collection, set extends collection. Collections can hold references to other objects. However, they cannot contain primitive types. So if I want a collection of integers or doubles or characters, I need to use the corresponding wrapper classes. Let's have a closer look at the interface collection. Here you can see the documentation. Let's scroll down a little bit. It has all kinds of useful methods to do things with collections. You can add an element, add a whole collection of elements, remove all elements, check whether it contains a certain object or maybe contain a whole collection of objects. It can check whether my collection is empty. It has an iterator, can remove one or multiple elements. It can remove all elements and just retain a certain collection of elements. Return the size of the collection. Notice an array uses length to let you know how many elements there are. Collections use the method size. It can also convert the collection into an array. There's one thing in particular I want to point out. We talked about interfaces, how those are contracts that are binding, forced by the compiler, contracts where you have to implement every single method that is specified. And yet, in this interface collection, I see optional operation, etc. As a matter of fact, in the interface collection, all the mutators are optional operations. Mutators are the methods that change the collection, like adding, removing, which is different from checking whether it contains an element or giving me the size. Those things are not optional operations. What does it mean to be an optional operation in the context of an interface that is a binding contract? So let's check it out. This is the part I want you to read. If a collection refuses to add a particular element for any reason other than that it already contains the element, it must throw an exception rather than returning false. So my add method returns a Boolean. I can return false if I can't add it because my element was in a collection, let's say in case of a set which cannot have duplicates. However, if I am just writing a collection and I don't want my collection to add anything, I want to have an immutable collection, the interface specifies this is okay, but I still have to follow the contract of implementing my method. What I have to do is I have to throw a special exception, and this is the unsupported operation exception. To have a semantic specified that allows you two different options to implement a method is fairly rare, so I just wanted to point that out. Now that we had a look at interface collection, let's see where it is commonly used. Interface collection is commonly used as a parameter type in methods. By specifying a parameter of type collection, I open a possibility to pass in any kind of collection, a list or a set or a queue, etc. Most collection implementations provide a constructor that has a parameter of type collection. The advantage is the following: you can create a new instance of a collection based on the elements of an existing collection. For example, I could create a new linked list and fill it with the elements of an array list. I could create a new array list, fill it with the elements of a set, etc. Now let's have a closer look at the interface list. Lists are ordered collections where the user has control where in the collection an element should be inserted or deleted. Lists have a zero-based index. They also allow to manipulate specified ranges of elements, search for elements, etc. Here you can see the list extending interface collection and the different classes, array list, linked list, vector, that implement the interface list. Let's have a look at 3 implementations of the interface list. Array list, that is a class that provides efficient random access. Linked list has efficient insertion in the middle. And vector. Vector is by default synchronized. That makes vector suitable for multi-threaded programming. Array lists are known for great performance. Let's compare array lists with linked lists. Array lists use dynamically resizing arrays to implement the list, while linked lists use a doubly linked list. Array lists have random access with an index, so I can just calculate the position of the 500th element, because in an array all the elements are stored in a continuous block of memory. Linked lists have sequential access. The elements are stored in different positions on the heap and they contain references to find the next and the prior element. Here is an image of a linked list. That's where it starts. So my first reference takes me to the first element, and here it says next. So I follow along the reference which takes me to my next element. I follow along the reference which takes me to my next element, to my next element, and there is no more next element. But I could go backwards. I could go backwards, and here previous. I could go backwards, previous. I could go backwards, and there is no previous element. If you compare the removing of elements in an array list versus a linked list, you can see that in the case of the array list, I have to reposition all the following elements. So if I remove one element, all the other elements have to be copied up one position. If I remove an element in a linked list, all I need to do is to reset 2 pointers, 2 references. If my array is small, like 20 items, that's not an issue. If my array is really big, like 20,000 items, that can be a performance gain. There's one more thing I want to introduce, and that is type inferencing. When you declare and initialize a variable in a single statement, the compiler can infer the missing type based on the context. Here you can see my variable, declared as a list of strings, initialized with a new array list. Notice, no type is specified here. This type is inferred. This is sometimes called a diamond because the opening closing brackets resemble the shape of a diamond. You find type inferencing on the right hand side in combination with the constructor. On the left hand side, when I specify the type of my variable, I have to provide an actual type argument, in my case, string.